Today we are going to discuss PDA to CFG conversion. Push-down automaton. Push-down automaton. The moves of a push-down automaton is represented by this. That means this is a question: generate context-free grammar for a given PDA defined by M is equal to. That means it is having two states Q0 and Q1. The input alphabet is 0 and 1, and the stack alphabet is X is at 0. Delta is the transition function, Q0 start state, and Z0 is the bottom of stack marker. Where delta is defined by, what is this? Delta of Q01 Z0. That means if Q0 is the current state and if the input symbol is 1 and if the current top of the stack is Z0, then Q0 is XZ0 means it is pushing X into the stack and staying in state Q0. That is the meaning. Delta of Q01X equal to Q0XX means if it is in state Q0 and if it is accepting the input 1 and if the top of the stack is X, top of the stack contains X, then it will switch to state Q0. It will stay in the same state Q0 and it will push X onto the stack. That is why this X is replaced by XX. That means after that X, one more X we are going to push. Here Q00X, delta of Q00X, current input symbol is 0 and if the current of the stack is X, then Q0X means nothing you are going to do. So you are neither popping nor pushing. That means nothing you are doing. That is, next is fourth rule, that is delta of Q0 epsilon X. That means without reading any input. Here epsilon means without reading any input. If X is on top of the stack, what will happen? It will switch to a new state Q1 and you have to pop this X. That means after that epsilon here means you have popped this X. Okay. Now delta of Q1 epsilon X equal to Q1 epsilon means if the current state is Q1 and you are going to read anything, and if the current of the stack is X, what will happen? It will switch to a new state Q1 and it will pop this X from the stack. And now Q1 0X, and if the current state is Q1 and the current input symbol is 0 and current of the stack is X, what will happen? It will push X onto the stack and stay in the same state. And Q1 0 is at 0. If the current top of the stack is at 0 and if the input symbol is 1 and the current state is Q1, what will happen? It will pop that. That is why here epsilon. So these are the moves, and you can pictorially represent these sets of by diagrammatically you can represent this. That means a push-down automaton is a finite state automaton plus a stack, FSI plus stack. That means here the stack is for memory. Stack is used for memory. So here what will happen? That means delta of Q01 is at 0. That means in state Q0, if the input is 1, that means if the input is 1 and if the current top of the stack is Z0, 1 comma Z0, what will happen? It is going to push X Z0. That means push X onto the stack. That is why here we have X Z0. That means in state Q0, if the input symbol is 1 and current top of the stack is Z0, then you are going to replace that Z0 with XZ0, means you are pushing X onto the stack. So that is represented by this. Now second rule, delta of Q01X is equal to Q0XX means if the current input symbol is 1 and current top of the stack is X, I am going to have a new rule here. That means if the input is 1 and if the current top of the stack is X, then that is replaced by XX. That means you are going to push X onto the stack. Then next is delta of Q00X equal to q0x means if it is reading input symbol 0 and if the current of the stack is x, you are going to do nothing. That means you are not doing anything. That means you are neither pushing nor popping. That means you are going to keep this x as such. So what will happen? That is next rule. If the current input symbol is 0 and current top of the stack is x, 0 comma x, what will happen? It is going to do anything. That means it is neither pushing nor popping. What is the fourth rule? Delta of q0 epsilon x. That means without reading anything, if the current top of the stack is x, it will switch to q1 epsilon. That means here you are going to switch to q1 if the current top of the stack is x and without reading anything. That means here the input symbol is x means you are going to that means input symbol is nothing. That means you are not going to read anything. That means you are not moving your input pointer. Without moving your input pointer, what are you going to do? That is q1 epsilon means, and if the current top of the stack is x, epsilon x, what will you do? You are moving to state q1 and uh, that is replaced by epsilon. That means this x you are going to pop. This x you are going to pop. That means without reading any input symbol, if the current top of the stack is x, okay, it is going to pop that x. That's the meaning. Now next one, fifth one, q1 epsilon x. That means without reading anything, epsilon, that means without reading anything, if the current top of the stack is x, what will happen? Current top of the stack is x, that is q1 epsilon x, what will happen? It will switch to q1 and we are going to replace that with epsilon. Okay. Now sixth rule, delta of q1 0x, delta of q1 0x is q1. That means again that is a movement from q1 to q1. Here q1 to q1 and q1 0x. If the current input is 0 and if the top of the stack is x, you are going to push x onto the stack. And the last one is delta of q1 0 is at 0. q1 0 is at 0 means here you are going to have q1 0 is at 0. You are moving to q1. That means if the current input symbol is 0 and current top of the stack is at 0, what will happen? You are going to pop it. That means here you are going to have epsilon. Okay. Here I have written this. This is PDA equal to a finite state automaton plus stack. That means here the moves of a push-down automaton is represented by this diagram. Push-down automaton is represented by this diagram. If there exists a PDA, there is an equivalent context-free grammar. PDA can be converted to a context-free grammar, and if you have a context-free grammar, you can easily convert that to a PDA. That means PDA and CFG are equivalent. PDA in the sense it is non-deterministic PDA, and non-deterministic PDA and context-free grammar are equivalent. If you have PDA, you can convert that to a CFG, and CFG can be easily converted to a PDA. Okay. These are the rules we have to follow. That is, the productions are, suppose that you have a set of productions, these are the set of productions, or these are the set of functions, delta of, these are the moves of a PDA. And once you have a PDA, then you can easily convert that to CFG. The productions are induced by move of PDA as follows. S productions are given by S. Production means start symbol production. S is the start symbol, and start symbol product. Every grammar, for every grammar, if it is a context-free grammar, there is a start symbol. S productions are induced by S derives Q0 is at 0 Q for all Q in Q. here we have Q is equal to Q0, Q1. That means here we have two elements in, or this set is having two elements, and there's a Q0 and Q1. That means in our PDA we have only two states, Q0 and Q1. Then what are the S productions? We assume that the start state is Q, and here for all Q element of Q you should have S derives Q0 is 0 Q, and a variable is defined like this: Q is at P, where Q and P are states and Z is a stack symbol. Q and P are states and Z is a start symbol. This is a variable in CFG. A variable in contextual grammar is represented by Q is at P within square brackets. Q is at P within square brackets, where Q and P are states of the this, and Z is a stack symbol. Okay. Now this is as per that this also is a variable. What is this? S derives this variable for Q0 and Z0. Q0 is the start state and Z0 is the bottom of stack marker. Z0, and forever if you have two elements in Q, then definitely you will have Q0 is at 0, Q0 and Q0 is at 0, Q1. That means this is the only variable. Here Q0 and Z0 are fixed. For all Q element of Q, or for all Q element of Q, that means this Q is having Q0 and Q1. Then if you are putting Q0 here, what will happen? This is Q0 is at 0, Q0. And if you are putting Q1, this is Q0 is at 0, Q1. Okay. And now, as per rule 1, this is rule 1. As per rule 1, we have S derives, what is that? Q0 is at 0, first element of this. Q0 is at 0, Q0. This is the first rule. S derives Q0 is at 0, Q0, and the second one is for this Q you can take the value Q1 also. That is why you have S derives Q0 is at 0, Q1. S derives Q0 is at 0, Q1. So these are the S productions. As per rule number 1, we have that two S productions. We have S productions. S derives Q0 is at 0, Q0 and Q0 is at 0, Q1. Here Q0 and Z0 are fixed, and this is varying. For this case it is Q0 and for this case it is Q1. Why? We have two elements in the set Q, and initially in this case you are putting Q0 here, and in this case you are putting Q1 here. Okay. And now for every popping move you have to find out whether it is a popping move or a pushing move or a push move. If it is a popping move, you have to follow this. What is that? For every popping move, delta of QA is equal to Q dash epsilon. That means if the current state is Q, current state of the PDA is Q, and the input symbol is A, and if the current of the stack is Z, it will switch to a new state Q dash, and it is popping this Z. After popping this Z, that means if the current input symbol is A, and if the current output of the stack is Z, and if the current state of the PDA is Q, then what will do this? After popping this Z, that is why here you have epsilon, and this will switch to a new state Q dash. In this case, it is inducing a production that this Q Z Q dash. This Q is coming from here. This Z is coming from here, and this Q dash is coming from here, and that derives a this A is coming from here. This is the way. Q A Z implies Q dash epsilon. If it is a popping move, then Q Z Q dash. This is the state, or this is the variable that is deriving A. Where does this A, from where does this A come? That is coming from this here. And the initial state Q is this, and the final state Q dash is this, and in between you have Z, which is the top of the stack. This is the way you are going to do. And third one is, for each push move, if it is a pushing move, what will happen? If delta of QA is equal to Q1 equal to Z1, Z2, etc. up to Zm, that is QA Z. That means if the current top of the stack is Z, current input symbol you are going to read is A, and if the current state is Q, it is switching to a new state Q1. After popping this Z, that is replaced with M stack symbols Z1, Z2, etc. up to Zm. That is, if you have a stack and suppose that Z is on top of the stack and delta of QA Z, suppose that the current state is Q and this is A, this is the finite control and it is reading the symbol A, and current top of the stack is Z, what will happen? QA Z, what will happen? It will switch to a new state Q1. That means this state, that means after doing this, it will move to the next input symbol and it is replaced with Q1. That means the current state is changed to Q1 and we are popping this Z, and what are you going to do? Pushing Z1, Z2, etc. up to Zm. That means Z1, Z2, etc. up to Zm. And now the top of the stack is having Zm. Top of the stack is having Zm. Okay. Now, if you have such a move, then you are going to have a production line Q Z Q dash. This Q dash is not part of this. Q dash is not part of this. Q Z Q dash. This Q is coming from here. Z is coming from here. And this Q dash is coming from nowhere. That means you have intentionally put it there. That is equal to this A is coming from here. A. Q1 is coming from here. Q1 Z1 Q2. Q1 Z1 Q2, then Q2 Z2 Q3. This is Q Z2. Z2 is coming from here and this Zm is coming from here. For example, suppose that here you have 10 stack symbols you are going to push, then here you have 10 variables. If you have a single variable, if you have a single pushing, that means a single stack symbol you are going to push, then you have only a single variable here. That means as many number of stack symbols are there as the number of variables. Okay. Here this is that, and now here Q1 to Q2 and Q2 to Q3, Q3 to Q4, etc. up to Qm to Q dash. That means this Q dash you have to write here. That means in the final variable, the last part is Q dash. Okay. That means here this Q dash is going here. And now same, this Q1 is coming from here, and if you write Q2 here, the same thing you have to write here. That means here Q3 is coming here. This is something Q3, and say here you have Qm. That those two should be the same. That means Q1 is equal to Q2, Q2 is set to Q3, Q3 is set 3, Q4, etc. etc. That means here this is a state. This state should be the start should be the starting of the next variable. That means here a variable is having two states. That is, this is the initial and final state, and in between you have a stack symbol, and Q1 is set on Q2. Then the next variable should start with Q2. Here Q2 is set to Q3, and the next variable should start with Q3, and like that. Okay. Now, rule number 1 already I told you. Now, rule number 2, that means depending on the production, depending on the move, we are going to have, that is rule number 1. See, next is, that is the, as per rule number 1, we have done S derives Q0 Z0 Q0 and S derives Q0 Z0 Q1. Now, I am going to make the productions for this rule. That means this is a move. Delta of Q0 1 is Z0. That is, the rule is delta of Q0 1 is Z0. Q0 1 is Z0 is equal to Q0 x Z0. Q0 x is Z0. Q0 x is Z0. See, here you are copying this Z0 and pushing x Z0 means you are just pushing x. That means initially that is having x, and after this it is having x Z0. Sorry, initially it is having Z0. That means Q0 and Z0 means the current state is Q0 and current input symbol is 1, and Z0 is on top of the stack. You are moving to the state Q0 after pushing this. That means you are going to push x. Now this is x Z0. Okay. Now what are the, here you have to ask, this is a pushing. Here we are pushing elements onto the stack. So you have to use rule number 3. So here you are going to use rule number 3. Here delta of Q0 1 is Z0 is equal to Q0 x is Z0. Okay. Now I am going to have, see, the Q is at Q1, Q dash. This Q dash can be either Q0 or Q1. Okay. That means you have production line Q, this is Q. Q is coming from here. That means initially you are going to have this one derives. Okay, what is this? Q0. That means here this Q is coming from here. We have delta of Q0 1 is at 0. This Q0 is coming here, Q0, and this Z0 is coming here. Q0 is at 0, and this Q dash. This Q dash can be either Q0 or Q1. Q dash can be either Q0 or Q1. Now I am going to push Q0 here, Q0 here, followed by, what is that? A off. That means you have to check what is the input. Input is here 1. That means 1 off. Here you have two stack symbols, so you have two variables here. This two variables. Then you have to move from Q0 to Q0, and you have the only other state Q1. That means if you want to move from Q0 to Q0, you can move from Q0 to Q0 to Q0, or you can have Q0 to Q1 to Q0. These are the two moves. That means here you are moving from Q0 to Q0, and then you are moving from Q0 to Q0. That means here you have to write Q0, 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 Q0. That means Here the final destination is, that means you have to move from Q0 to Q0, and as it is having two symbols x, z, 0, that means as it is a pushing and you are going to push two elements, that means you are popping z0 and then pushing x and z0, so you have two elements you are going to push. Here you have two variables. As you have two variables, you have to start from Q0 and you have to reach Q0 as per this. And in either you can move from Q0 to Q0 and then Q0 to Q0, or another possibility is there from Q0 to Q1 and from Q1 to Q0. These are the two possibilities. If the final destination is Q0, you can move from Q0 to Q0 and then Q0 to Q0, or you can move from Q0 to Q1 and then to Q0. That means here after writing this, you have to write x here and z0 here, x here and z0 here. Okay, so these are the two productions. Here also left hand side is Q0, Z0, Q0 derives this one. Now suppose that this Q dash, Q is at Q dash, that means Q0, that means next left hand side is Q0 is at 0, and here you have Q dash. This Q dash can be either Q0 or Q1. As you are having two elements in this, here this Q dash can be either Q0 or Q1. That means if Q dash is Q0, we have developed two productions, and if this Q1, what will happen? If this is Q1, what will happen? Again, the input is 1. That means this here also you have 1. This 1 will come here, 1. And x is at 0. You have two variables. Okay. Here in this case also you have to move from Q0 to Q1. If you are moving from Q0 to Q1, either you can move from Q0 to Q0 and then to Q1, or from Q0 to Q1 and then to Q1. That means here either you can move from Q0 to Q0 and Q0 to Q1, or another way is also there, from Q0 to Q1 and from Q1 to Q1. Okay, that is, this is Q0, Z0, Q1. That means you have to move from Q0 to Q1. You are moving from Q0 to Q1 and then to Q1. That is 1. So these are the four productions we have derived for this. These are the four productions we have developed for this, as it is a push operation. Okay, now we are moving to the next one, delta of Q01x, Q0xx. See, this is delta of Q01x. Q01x is equal to Q0xx. Q0xx. Okay. As per rule number, this is also a pushing operation, and as per rule number 3, here you have to start from Q. That means here you are going to have, here it is Q0 and here it is Q0. There are two possibilities. Now I am writing this like this, is equal to, here you have two variables, then here you have one, this is the one, and here you have one. Now if we are moving from Q0 to Q0, there are two possibilities, Q0 to Q0, two possibilities, and those two possibilities are okay. Now if this is Q1, if this is Q0, you have two possibilities, and if this Q1, Q0 to Q1, and again you have two possibilities. Okay, equal to, or this is actually deriving. This is not equal to, this is deriving, and deriving. What is this? Followed by this followed by this. Okay. Say here also Q0. For all these cases, this Q0 you have to copy here. That is a starting. Okay. Now, what is this? This Q dash is either Q0 or Q1. That means Q0 or Q1, and you have two cases which is Q0, and for two cases are there for Q1. Now it has to move. Here you have two variables. Why? Two elements you are going to push. So two variables are there on the right side, and as it is reading 1, here you have 1, and 1. This x will come here. This is x, this is x, and x. Okay. Now xx means this is x, and x. Okay. Now here you have to move from Q0 to Q0. So initially here it is Q0. You have to start from Q0 and you have to reach Q0. Here also you have to start from Q0 and you have to reach Q0. Here also you have to start from Q0 and you have to reach Q1. Q0 and this is Q1. Q0 to Q1, Q0 and this is Q1. Okay. Now if you are starting from Q0 and you have to reach Q0, either this is Q0 and this is Q0. You are moving from Q0 to Q0 and Q0 to Q0. If you are moving from Q0 to Q1, then you have to start from Q1 and return back to Q0. Now what about this Q0 to Q1? Q0 to Q0 and Q0 to Q1 and Q0 to Q1 and Q1 to Q1. So these are the four productions we have developed using this move. This is a move. This is a deterministic finite state automata, and using this move we have developed the four productions. Okay. Now next is rule number 3. It is not rule number 3. It is move number 3. We are going to consider, that is delta of Q0 0x. Delta of Q0 0x is equal to Q0 0x is equal to Q0x equal to Q0x. That means you are neither pushing nor popping, but we consider this as a pushing move. Why? You are popping this x and then pushing x. That's why here we are going to have this. We are going to consider this as a pushing move. That means here, as it is a pushing move, again you have this Q0 you have to copy here. Q0 you have to copy here, and Q0 equal to, and the final destination is either Q0 or Q1. That means here, as it is having only a single element push, that means you are going to push only one element to the stack. Here we are having only a single variable. Okay. Here from Q0 to Q0, here you have Q0 and this x you have to copy here. Q0 is equal to what? 0 of from, you have to start from Q0 and you have to reach Q0, and here you have to use this Q0 x Q0. That means in between, that means you have to reach Q0. Now another one is from Q0, that means this Q dash is taking different values. The first case is Q0 and the second case is Q1. Q0 to Q1 you have to move. Then this x has to be copied here equal to, this is not equal to, actually it is this one, and this is 0 of, then you have to copy, you have to start from Q0 and you have to reach Q0. That's why this Q0 you have to copy here, you have to reach Q0, that is from Q0 you have to reach Q1, here you have Q1. That means these are the, here we have only two productions. Here we have only two productions. Now, next is 4. 4 is actually, it's a popping operation. 4 is a popping operation. That means delta of Q0 epsilon x. Delta of Q0 epsilon x. Delta of Q0 epsilon x is equal to Q1 epsilon. Equal to Q1 epsilon. Delta of Q0 epsilon x is equal to Q1 epsilon as it is popping elements. If you have popping elements, this is delta of QA z is equal to Q dash epsilon. In that case, Q is at Q dash. That means Q is coming from, that means here this is 1. This Q has to be copied from here. That means here you have Q0. This Z has to be copied from here, Q0x, and this Q dash has to be copied from the right hand side. That means this Q1. Q1 derives what? A. That means this is epsilon. That is, this is as per rule number 2. This is rule number 2. That means this fourth case is, it is reading without reading any input. It is popping an element x from the stack. That is why Q0 x Q1 is equal to is deriving epsilon. This Q0 is coming from here, and this epsilon goes here, and this x comes here, and this Q1 comes here. Okay, that is rule number 2. And next one is is 5. Delta of Q1 epsilon x is equal to Q1 epsilon. Here also it is a popping operation. Delta of Q1 epsilon x. The rule number 2. Rule 2. Delta of Q1 epsilon x. Q1 epsilon x is equal to delta of Q1 epsilon x is equal to Q1 epsilon. Q1 epsilon. Here also it is a popping operation. Here that is converting to this. That means Q is at Q dash. That means here this Q1 you have to write here. This Q1 you have to write here. This x you have to write here. Determines this epsilon go here, and Q1x Q1 derives epsilon. Okay, and that is the fifth one. And the sixth rule is sixth one is a pushing operation. Sixth one is a pushing operation. Here this is sixth one pushing operation. Delta of Q1 0x. Delta of Q1 0x is equal to delta of Q1 0x is equal to Q1 xx. Q1 xx. Okay, that is here as this is xx. From Q1 you have to reach Q0. That means here we are going to have again derives 4 productions. Number first production, second production, third production, and the production is this one, last production. Here, see, listen here, Q1 you have to copy here, Q1, 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 Q1. Okay, and now this side can be either Q0 or Q1. Now, for two productions it is Q0 and for two productions it is Q1. You have to start from Q1 and you have to reach Q0, Q1 to Q0, Q1 to Q1, Q1 to Q1. Now this 0 has to be copied to this place 0, 0, 0, 0. Then XX. So here it is X, XX, XX, XX. Okay. Now, has to start from Q1 and you have to reach Q0. There are two possibilities. Start from Q1, Q1 to Q1 and Q1 to Q0. That means you have to start from Q1 and you have to reach Q0, Q1 to Q1 and then to Q0. Next is Q1 to Q0 and Q0 to Q0. Okay. Now what about Q1 to Q1? Q1 to Q1 is Q1 to Q1 and Q1 to Q1. Or if you are moving from Q1 to Q1, Q1 to Q0 and Q0 to Q1. Okay. Here, this X has to be copied to these places. X, 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 X. These are the four productions. These are the four productions. And the last one we are going to discuss is, this is the case we just discussed is not rule 2, it is rule 3. Now this is rule number 2. Delta of Q1, delta of Q1 0 is at 0. Q1 0 is at 0 is equal to Q1 epsilon. Is equal to Q1 epsilon. Delta of Q1 0 is at 0 is equal to Q1 epsilon. Here we are going to have, this is, that means it is a copying operation. Here Q is at Q dash. That means this Q dash and this is at. Okay. That means this is Q1 and this Q1 comes here and this is at 0 comes here and this 0 will go here. 0. Okay. This is the last one, and with that all the productions, all the moves have been converted to its equivalent productions, and with that I am concluding the session. Thank you.